Reciprocal trigonometric functions. We're going to sketch each of the following function. So we're going to sketch y equals 1 over sine x. So to do that, I'm going to graph sine x first. And again, I'm using pencils because that's not going to be my final answer. So I need a scale in here. I'm going to, just so that my amplitude can be spaced out a little better, I'm going to put every 2 squares as 1 unit. Along here, every unit will be pi by 2. So I'm just going to label every second one. Okay, so let's graph sine. So remember, sine starts with the origin and it goes upward to the max, every pi by 2 squares. So every square has to cross through that median before going to the min, and so on. So it's got this general shape here. I'm sure it goes through that point. Okay, let's continue it on to the left. And so it's got this general shape again here. So I'm going to label this y equals sine x because I want to leave it here for us to see. Now, let's apply what we know about reciprocal functions. The x-intercepts have to become asymptotes. So you've got an asymptote here at x equals negative 2 pi. You've got an asymptote at x equals negative pi. You've got an asymptote at x equals 0. So you got several asymptotes now. So every x-intercept becomes an asymptote now. We don't always label them on these graphs just because of all the how many asymptotes there are, but it's still a good idea if you want to. Now, invariant points are really important to look at. So our invariant point is where y equals 1. So that would be our max. The other invariant points where y equals negative 1, that would be our min. So these points, the max and min, do not change. Now, we need to look at some other invariant points. We have, the other key point we have is this would be at 1/2. So 1/2 becomes 2. So that's actually at the top right here. So where 1/2 was, this is now 2 because that's the reciprocal. Where 1/1/2 is, this would become 2. So what's actually happening now is the graph is going upward. So it's not approaching the any asymptotes on the x-axis. It's just approaching the vertical asymptotes. Let's look over here. Negative 1/2 becomes negative 2 because that's where negative 2 would be. 1/2 becomes negative 2. So you're going to get all of these U shapes alternating within here. So 1/2 becomes 2 again. So you don't need to draw in a horizontal asymptote since the graph is not approaching that. So this is one of the few instances you do not have that with the trig functions here. Okay, so we're going to label this as y equals 1 over sine x. Now I want to make a note. Y equals 1 over sine x. We've used reciprocal functions before. This is really cosecant x. So this is the graph of y equals cosecant x.